Satellites play a critical part in our everyday lives, from broadcasting television to providing the infrastructure for how GPS works on your phone or in your car. Additionally, a lot of those awesome space photos that you see online were taken by imaging satellites up in space. However, satellites have to get all the way up into space in order to work, and the process for getting them there is expensive and difficult. Today, we're going to be looking at the different steps which go into getting one of those satellites into orbit. So, some of you have probably seen footage of a rocket launch, either bringing astronauts into somewhere like the space station or a satellite like we'll be doing today. Rockets are fairly simple in concept. As you can see here, there are a lot of fuel tanks, which are containing the liquid fuel which we'll be needing to power our engines. And additionally, we'll need the engines which consume the fuel and propel us into space. So, upwards at the top of the craft, you'll actually see the different computer systems which will allow us to remotely pilot the rocket. And so that way, we don't actually have to have an astronaut piloting the ship, which would put them in danger. Additionally, computer systems will make very, very tiny adjustments with our engines down there and allow us to keep a very straight and accurate path, allowing us to not diverge off and start crashing into the ground. So, now that we have our ship built, we can go ahead and begin the launch process. Now, in real life, they'll do a lot of flight checks to make sure everything goes perfectly, but since this is a simulation, I can just reload in case everything explodes. One thing to note is that to the left of our trackball down there, I actually have the throttle a little bit below the max 100 setting because if we go too fast, we'll actually start burning up in the atmosphere, such as like a meteor. And that's actually because we're hitting the air molecules in the atmosphere so fast that we actually start to have a lot of friction, which will start to burn up our spaceship, which obviously we don't want. You also notice me doing a little bit of nudging of our spacecraft in that direction to the right a little bit, and what that'll do is expand our orbit about a little bit and actually allow us to have a bit of a wider trajectory. So you can see our trajectory is going further and further out into space. And that is called our apoapsis, which is basically in a orbital mechanical standpoint, the point at which we are the slowest in our orbit. And now that we have burned through most of the fuel, we can go ahead and eject our boosters, which were just there to get us all the way up into space. It actually takes an incredible amount of fuel just to get us into the atmosphere, and most of it was just used for getting us that initial jump point. Once we're actually in space, however, it's actually a lot easier to accelerate with less fuel because we don't have to worry about air slowing us down or the gravity from the Earth being quite as strong. As you get further away from the planet, it actually gets weaker. So now we can start doing our gravity turn, which is when we are going to actually position our ship parallel to the surface of the planet. And what that'll do is instead of burning and putting our orbit further up, as you can see here, it'll actually allow us to expand it. And instead of just going straight up, we'll actually start to expand our orbit off to the sides, which once we burn that way for long enough, will allow us to enter orbit. So I went ahead and added an orbital maneuver there, which we are slowly approaching. And once we get to that point, we will start burning parallel to the planet and doing, as I just said, expanding our orbital trajectory. Okay, so we're there now. So we're going to start burning here to get us that nice orbital path. As you can see, our boosters are going to be left behind. We don't want those entering orbit as they essentially just clog up the atmosphere. So we're going to allow those to fall back down to the planet where they will not get in our way or in any pre or future launches in their way either. So you can see that blue path is where our actual trajectory is right now. And what we're aiming for is that dotted yellow path. That's where we want to be. So, as we burn parallel to the planet, our actual orbit is going to start expanding, and right there, we officially have entered orbit, and we're going to continue expanding a little bit to make sure that we are all the way out of the atmosphere so that it doesn't slow us down. So, now that we've finished burning, we can get rid of our engine there as we will no longer be needing it. And additionally, now that we have a good path around the planet, we can go ahead and deploy our satellite, and it'll serve whatever purpose it was designed for. Additionally, we can go ahead and deploy our solar panels here to keep the satellite powered, but beyond that, we're good to go. Going to go ahead and also position our satellite so that the communication array there is pointing towards the planet, so that way we're not broadcasting out into deep space. And I hope you all learned a thing or two about how satellites get into space, but beyond that, we are good to go. Thank you for watching.